So here's a very similar program that creates a variable v. It takes v's address, but this time I put it in a variable p so that it really will. You can imagine that this box is p because it contains the address of v. Now the type that I give p, p does have a number, but more specifically it has a number that's meant to be the address of an integer. So that's what this type in front of p means. A star means an address of this kind of value. So p holds an address. I've set v to 6 actually before I start printing. And now I say at %p. %p is referring to variable p, which holds the address of v, so that is telling us the address of v. Star p, this star is meant to relate to that one. When we put a star by itself in front of a variable, that means this variable should hold an address, and star gets the value out of that address. So it's the opposite of ampersand. It takes an address and gets the value out, as opposed to taking a variable and getting its address out. So this time we should see something about the address and the value 6. We'll just run it just to make sure we've got a valid example here. And there we go. Again, the address can change every time because v can move around. P will refer to wherever it is this time, and 6 is the value inside that address. Again, there's that picture. P lives somewhere, v lives somewhere, and the value of p is the address of v. When we use star p as an expression, that means get the value out, but when we use it on the left-hand side of an equal sign, that means put a new value in. So I've started off with v equals 5. I've made p hold the address of v, and then this says where p points to, set that place to 7. So what's going to happen here is that v will turn to 7. Right? Even though you don't see an assignment to v, there's an assignment indirectly by assigning to whatever p points to. And when we run it, we see that v is 7 after we assign to it. This program is similar to the one we had 2 times before, but with slightly different notations. All this part is the same. We're going to have at p is the value, but instead of using star p, I have p square bracket 0 square bracket. This means the same thing. Pointers like p, you can use star to get the first thing, or you can treat them as an array and use array notation to get 0 means the first thing, 1 means the second thing, and so on. So when I use p of 0, that's the same as star p here. We'll get the same 5 that we would get if we just used star p. When we run that, we get 5 as expected. Okay. Now in this case, we are saying p is the address of v, and instead of 0, I'm using 1. Now what that means is that p has the address of v. V has a 5 in it, but 1 would get the thing after that. Right? 0 is the same as star. 1 is the same thing as moving the address forward by an element, and we don't really know what's there. It can change every time we run this program. This notation, p plus 1, says take that address and add 1 to it, so it's going to report the address that we're using. So we put that in, run this program, and this time we got that random large number. Maybe it's the same, maybe it's different. No, it's going to be different. Okay. So this is an important fact about C as compared to Java. There are many C programs that you write, that you can run, that don't necessarily have a dependable meaning. Right? The standard doesn't say what they mean. The machine can pick different results. Right? And that's what we mean when we say C is an unsafe language. It doesn't specify what's going to happen for all programs that it will run.